So we are going to be discussing the pain gate theory, and as we go along we're going to add to your notes and kind of supplement in a little bit. So you see this picture here. We have a patient's spinal cord here, our little x-ray vision, and here is the spinal cord itself. We're going to be talking about the slow and the fast systems. So in your notes you have a slow system that is going to be related to our pain sensation. Now the receptor for the slow system is our nociceptor. So this is our nociceptor. It's our receptor for our slow system. And then we have our mechanoreceptor down here is our receptor for our fast system. Okay. Now, we know that there's a C fiber is going to be the neuron that carries our reception of pain from our nociceptor, and our A fibers or alpha fibers are going to carry the sensation of touch or pressure on our A fibers from our mechanoreceptors. And we'll notice that both of these are headed towards the same, what's called an interneuron here at the spinal cord. So they're going to the exact same location, and that's going to be very important when we think about the pain gate theory. Okay, so we have two different sensations. We've got the painful sensation, stabbing our tortoise here, and we have the sensation of touch on our rabbit there. And we're going to see what happens when these two sensations happen at the same time. Okay, so we see that the rabbit made it to the spinal cord much quicker than the tortoise did. I think we kind of might have expected that based on, you know, what we know about the tortoise and the hare, but we're not surprised that the rabbit made it there first. Now that interneuron at the spinal cord is going to be very picky about its signal. So it's going to accept a single signal. So the rabbit won the prize and made it to the spinal cord first. So that interneuron is going to take the rabbit signal, which is our proprioception, and it's going to send that signal up to the cortex. Now, the interneuron, it sends a signal and then it needs a rest break, and this is called the refractory period. And that refractory period, it's unable to send a second signal. So by the time that the tortoise signal made it to the interneuron was resting. And therefore, it does not send the pain signal up to the cortex because it's in its rest phase. Now, this means that the cortex does not feel the pain signal. It doesn't ever get that pain signal. It does not mean that there was a reduction in harm to the body part, but the brain doesn't feel as much because the pain signal got to the interneuron slower than the touch or proprioception signal did, and therefore the interneuron was resting when the pain signal came in and cannot transmit it up. This is going to be so important for us when we talk about why our modalities are effective in helping reduce our pain. We're going to be using the pain gate theory.